As I said today, we're talking about visualization tasks. This is a very useful way for us to think about what we want to do with visualizations and what people can do with visualizations. This is one of those chapters from the Munzner book that you should read. It will be very much used in a lot of your assignments and questions and projects. It's a good explanation. So I'm going to do my best explaining it, but the book is there for you to also read it. So when we think about visualizations, we're generally dealing with two people, at least, right? The designer or the author and the viewer, the reader, the person who is viewing the visualization. So the designer is the person who chooses what the viz should do, and they have communication goals, as we've discussed. They could be thinking about storytelling and other stuff. The user, viewer, end user has goals, beliefs, attitudes, and ask, what can I do with this visualization? Not that they ask it consciously, but this is a question that's important, right? Like when you might, even in a news article, you might show a bar chart. If the user already knows how they can read, that's basically what they're asking, right? They quickly will say, oh, this is what I can do with this visualization. So this is what we're talking about, user tasks, right? So there's a lot of work in the visualization literature, and I've again pasted this paper for you in the list. One of them is Martin Sko, who created a taxonomy of user tasks in visualization environment. Some of them are to retrieve a value, to filter, to compute a derived value, to find extremum, to sort, to determine range, to characterize distribution, and to find anomalies, and to find clusters, and to correlate. These are some of the tasks that Stasko and Amar have identified. So we're going to look at these and just think about how visualizations might support some of these tasks. You can think about these are the things the users can do with a visualization. Okay? So let's think about retrieving a value. So the idea of retrieving a value is to find attributes of a set of specific items in a data set. Okay? What find attributes means so like for all of the Mario games in a data set, what is the sales prices of those? What was the global sales of Mario Odyssey? What is the Rotten Tomato rating of Penguin? When was the release date of X album? This is something that we all do very intuitively. This is a type of question that we ask, right? So to retrieve a value from this visualization, we ask, hey, first find Super Mario Bros. What is the value, the global sales of Super Mario Bros? Oh, it's the first one, and then you come here and then you retrieve that value. It's a truism what I'm saying. It's like just pretty intuitive, right? But it's a task. You want people to be able to retrieve values from a visualization for a specific item in your data set about a specific attribute. So this global sales is an attribute. This is a specific item, and that's the value you're getting. Okay? All right. So now let's try to make this visualization that allows us to do this. I've already imported the data set, right? But as you can see, the data set has 16,598 rows. I am not going to need all of those. I'm going to create a subset of those. So I've shown this to you before, but I can filter the data set. So I can go Mario games equals video games data dot filter, and then this is an anonymous function. Inside that, you can say return. And then what can we say? We can say d.name to lowercase includes Mario. because there's a lot of different Mario games, right? We just wanted to include the string Mario. Okay? So let's see what happens. Oh, so you know what's happening here? There are some games that probably do not have values. So I just need to make sure that those are strings. I think this should work. Yep. Okay. So there are 133 different Mario games. We want to look at, let's say, we want to ask what are the Mario games that have sold, let's say, more than $20 million globally. So you can type D global sales more than 20, and now you have filtered it down to only a few. Okay, so now we can use this. We can go vl.mark bar data. We pass the Mario games array that we created, encode, and then we're gonna go vly. The field for the y-axis is nominal. We're passing name. We can give it a title. And then we can go VLX. This is going to be the quantitative. So we can pass global sales. And then the title will be global sales millions. Let's see how it looks like. We're going to run render. Okay, we're getting there. It's close to what we looked at. Maybe we want it to be sorted to find the one with the maximum, but this supports the task of finding a maximum anyways, because you just find the one with the biggest size. Okay, but to sort it, to make it easier for people, you can just do sort, and I've shown this to you before, minus X. If you do X, it will be with the other one. Okay, then you can like also go vl.color. You can just give it a color to all of them, and then this makes it similar to the visualization that we created. Okay, any questions? So that's how we retrieve a value with one visualization, but you can do this with many different visualizations, but this is just an example of creating a visualization that allows us to retrieve the amount of sales for Super Mario Bros. Okay, so the idea is to given some concrete conditions, to filter is to given some concrete conditions on attribute values, find data cases satisfying those conditions. What were the sales amounts of top 5 games in Japan? What action games in North America had the most sales in 2020? So you have questions, and you want to find the subset. It's about finding the data cases. Okay, so this allows you to find the games that sold more than X amount over the time easily. Okay, should we create this? Let's create it. Is any of you following the coding parts, or should I just let it go and be done quickly, and then you just can read the code? Because I have the code samples here, but you could, I don't want to, I'd like to do the live coding if you all are doing it with me. Any thoughts? Good. You should eat, but follow. I'm going to do a couple of these, and then we'll see how it goes. Okay, so we want to create a chart to visualize game sales over time. Maybe we use a different mark this time, mark tick, and then we pass the whole video games data, and then we do encode VL by, We're going to do quantitative JP sales, and then we're going to give it the titles of Japanese sales. And then for X, we're going to do ordinal. That would be year. And the title would be year. Okay, then we run render to see what we have. Okay, this gives us what we need. Essentially, we can find the subset of values that have a certain criteria in terms of, or what year the game X sold the most amount, or what game was sold. So we can totally do some sort of filtering. Again, visualization wise, we can do the filtering for people and help them find them much more quickly if the question we're going to ask is much more simple, much more defined. In Vego Light, you can create a condition to highlight something conditionally. The way it works is by passing an object and saying test, and then datum JP sales larger than, let's say we want to highlight the ones that are larger than 5, and then the value should be orange. Now it's not visible enough, we can do red. So now we have highlighted, we basically are saying if the Japanese sale is higher than 5, do the color red, otherwise do it differently. And this becomes a really good visualization for you to essentially highlight a subset that's important to you. Okay? So this was to filter. We help them filter, basically ask, given some concrete conditions, let's say find the items that sold more than 6, find data cases satisfying those conditions. So this visualization supports this task. How about compute a derived value? Given a set of data cases, compute an aggregate numerical representation of those data cases. So this is something that you can do in your head, right? What was the total sales of different platforms? Or what was the average sales of different platforms for different years? Like this visualization allows us to get for example, directly the average sales of each platform for each year. However, you could also design it in a different way. You can design it in a way that people would have to compute that mentally, or you could introduce filters. But let's create this. This is a visualization. Again, a lot of these are things that you can use for your assignments because we be like that. We show you the responses. That's how we roll. Okay, so we want to do platform, and styles would be global years. Okay, so let's do this. So I'm going to do VL mark circle, and then I'm going to do data, video games data, and then I'm going to encode. I'm going to close encode and then call render here. And then for Y, it will be field Q. What will it be? Platform? Yeah. Platform. Let's see if it works. Why does it give it? Oh, it shouldn't be field Q. It should be field N. Okay. So we're getting all the different platforms here. And then VLX should be field O year. Okay. Now we're getting somewhere. And now we want to do the size. We're going to do the size. We're going to say VL size field Q global sales. And then this is getting all of them. We want to show the average. So we're going to do aggregate and then mean. This is important to do aggregation sometimes, because as you see, this is just getting the global sales of all different games for that platform. Now we have done the average sales of each platform for it. We can also do a median, or we can just do a count. Okay, these are different aggregations, but let's just do a median for now. Remember, I'm just going to show you how to make this into a heat map. It's very similar, so I can make this mark bar, and instead of color, I'm just going to, instead of size, I'm just going to do color, I think. And this will get us a heat map of sorts of the same visualization. Should also do filter and get rid of this NAs for your assignments. Cool. So how do we characterize a distribution? We have a whole session for distribution. The idea is to, given a set of data cases and a quantitative attribute of an interest, characterize the distribution of the attribute values over the set. What is the global sales distribution? What is the count distribution of games? For example, how was game sold over the years, or X, like just how is basically each platform selling? Essentially, that's what you want to do. Again, this is a whole kind of topic for us, so we're gonna skip this for next session. How do you find anomalies? How do you find the weird like cases and the more interesting cases? Identify any anomalies within a given set of data cases with respect to a given relationship or expectation. For example, statistical outlier. So we might ask, what were the games that had so much higher game sales than others? Or are there games where Japanese sales were more than North American games by far? So visualizations are generally really good to show you the anomalies. We had a case yesterday for number of cases, but for sleep hours or something, where someone said like a really high number, or it was something else. So there's the North American sales of this game is anomalous. The Japanese sales of this game is anomalous, right? So this visualization helps us find that. So let's make this visualization as well. So we're gonna do global sales for Y, for X, we're gonna do Q, and this is also Q. JP sales. We can rotate them like this. You can change this to EU sales. You can make this NA sales. It doesn't matter. Okay? So you can find the anomalies. So what is interesting here? What can we do? You can basically, it's a really good idea to highlight some of those anomalous things for people to see if that is what you want people to do. For example, you can say, show me, and I've shown this to you before, I'm going to repeat it because highlighting is really important, which you can say JP sales is larger than 5. And you use quotations for this as well. I'm sorry, I should have put this inside of a color. VL color condition, and then you want to give it value red, and it's giving us that set. Here you can also use an or. You can just say ones where NA sales is larger than 15. And I've shown you here that you can compare. So you can say, show me the ones that Japanese sales, because in most cases, North American sales are higher. But there are some games that, like, it's just there is much more sales in Japan. Given a set of data cases, find clusters of similar attribute values. That is a very interesting task. You can here, for example, ask what genres sell similar to action games, for example, right? So you can see that, oh, there are some genres that are like puzzles and simulations that have similar, like the same amount of globe sales, and then there's like action and sports and like platform that are a little bit higher. You can see shooters are like have a lot of higher sales, so you can find similarity in attributes. Okay, so we're gonna make this as well. I'm gonna bore you with a lot of examples because this is what the class is. VLX. So the field is quantitative. So you're gonna do North American sales, and then VL dot Y should be marked tick, right? And then we want to do field nominal. We want to do genre, and then we want to do render. I have a typo here. Okay. Now we can also color these differently. You can ask it to not show legend. There's something you can do. This is like new. You can just also just allow people to explore what games are the ones that sold a lot. So you can add a tooltip. And for tooltip in Vego Light, where we have a whole session on interaction. You pass an array, and then you can just say the fields that you want to be shown on the tooltip. So field Q, NA sales. So we can now see that this game is Wii Sports. This game is Super Mario Bros. This game is Duck Hunt, so far and so forth. And this game is probably Tetris. Cool. This is the, Super Mario Smash Bros. The fighting game fans. It's all Tekken 3 is the highest sales. Okay. So here's how we find clusters. So for correlate, you can, again, we're going to have a little bit of more information on correlations. The idea is that given a set of data cases and two attributes, determine useful relationships between the values of these attributes. Is there a relationship between average age of players and the amount of sales? Is there a relationship between average age of players and in-game purchases, etc., etc.? So we're going to do this set of questions later. But now that we've thought about these tasks that Martin Sko, which are really useful, we're going to look at another way to categorize these tasks. Because viewers don't usually think in these terms, right? You don't really think, hey, I want to correlate, right? We need to translate with these more abstract computational tasks to more concrete tasks. Is there a relationship? What variables to relate? Correlate X and Y. So you can use a scatter plot. So you're going to be asking a lot of sort of more specific questions as a user. So I just want to enjoy, right? I just want to present something to other people. That is the task that you want to have. I want to discover something from the data. I want to add my own knowledge. Again, these are all the tasks that you can find in the Monsner book. The idea for the analyze, consume, discover is to find new knowledge, to have this aha moment, to explore existing questions, to generate new questions. And it's hard to know these in advance. So looking at this map, let's see if we can open it actually. Looking at this map, you're going to ask, You're gonna develop knowledge. You want to analyze this map and learn something about the United States. For example, you can see that there's percent of average cumulative snowfall. How has it changed? And you can see that like in some areas there has been so little, and there's been more in these areas in the United States, right? Or which parts have gone colder and warmer in those years. Again, you can learn a lot by these different visualizations to find something that you didn't know before, or just generate a new question. Okay, so why has this happened? Is it because of climate change? That's a new question that you've generated. You might want to present something to someone else, basically something you understand. Persuade, to tell a story. So we have had a whole session on this, right? A lot of times you want to highlight something, you want to annotate something, especially in these polarized times. Like these days, we want to show how bad the situation in Iran is to people who are non-Iranian, right? So sometimes we make data visualizations, make animations. So, like, I personally think that this is something I want to show to you, right? I'm passionate about movies, and I wanted to show you that movies have gotten worse. First of all, it looks like movies have kept selling more, right? But is this true? What if we adjust for inflation? Like, movies have been selling a lot. And Endgame actually have sold less than Star Wars in terms of if you want to look at inflation. But in general, like, even if you see these, don't you agree? Do you all agree that movies have gotten worse over time? Like 2020 movies are just really bad? Why do we have a second Aladdin that's so awful? Like there was where is it? Yeah, that's possible. But I'm trying to say that yeah, like the sales have reduced for sure, and be a lot of this is like up till 2020, so maybe streaming hasn't been that popular, or maybe it was. But overall, like you can really see what movies were top selling in 2020, and then compare it to like make a moral judgment, if you will. So the 2020 ones were Top Gun, Maverick. It's an awful movie. Spider-Man. Let's look at 2000s. Lord of the Rings, Harry Potter, Attack of the Clones, Mission Impossible. They're all awful, anyways. But look at 1980s. If you're an old head like me, you would find a lot of interesting movies. Anyways, so I'm presenting to you. I'm presenting something I'm passionate about. I might be wrong or not, but this person is making that case anyways, right? Which movies have returned an investment between budget and everything. Again, so you can do a lot of these sort of presentations using visualizations, right? So another way to analyze is also to consume and just enjoy. You can engage, you can intrigue, you can provoke. So I show you these cases, a graphic designer from Paris, that they really wanted to show different interactions from Wong Kar-wai movies. Oh, someone said something. The loss of director did really contribute to the decline of movie sales as well. Yeah. Yeah, I've stopped using DVDs as well, even for video games. Let's get back to this though. So yeah, look, like this might not mean anything, but you can really analyze how over the case of the movie interactions between the two characters of the movie In the Mood for Love, which is a really good movie, have changed, right? Like in the middle of the movie, they have a lot of interactions. There were moments of solitude. I think this is an enjoyable or the movie started at night, then it was during the day, then it was at night. So it's an interesting approach, right? Another way to analyze is to produce and derive. Essentially, this idea is fundamental to discovery. You change the visual encoding to make it easier for people to visually do this, to derive values. We've already talked about it, right? You want to help people do operations on the data, make it easier to derive those values. So we already did this, right? You really, when you make visualizations, and I'm going to expect this for you, is to think about how you do this, right? How would we make this easier for people to see? So this is a visualization where sales of games in Japan is more than sales of games in North America. We can actually calculate the difference for them and show them the difference. I want to show you how you do that. So let's do this. The first thing we want to do is do a little bit of JavaScript. So we can say video games with difference equals video games data. I'm going to make a new array. I'm going to do map. And then I'm just going to say d dot difference, actually NA Japan difference equals d NA sales minus the Japan sales. So what I'm doing here is I'm calculating the difference and I'm returning these. So I'm making a new array here. So now I have calculated the difference between NA and Japan. So what can I do? I can make that visualization. So I can make VL, mark tick, data, video games with difference is our data set, encode, VL.x, field Q, we're doing NA JP difference, the difference between Japanese and NA sales. And then I need to actually close this and then do render. I need a dot before the encode. Okay, now we have actually calculated that derived value. What else can we do? We can also highlight them for them. We'll color, condition, test. We want to say, so NA JP difference is less than 0. And then we're going to do value red. So now we're showing the games that sold more in Japan. And then we want to actually help people identify them too. So we're going to add a tooltip as well. Okay? So we have Super Mario Bros. We have a lot of the more Japanese games that sold more in Japan. And what's the highest sell? Monster Hunter. Something wrong with Monster Hunter Freedom 3. The one that sold most. Wii Sports, interestingly, has sold a lot in America, in North America. Okay, so yeah, this is how we basically help people produce and derive. And then it's easy to turn the visualization that we just had into by platform. Very easy. You just add a Y encoding and you say field N. You can do by genre. Okay, role playing has sold like a lot in America. You can do it by platform, so you can make these visualizations super simply. The idea is to record, is to help people save, screenshot, help them record sort of findings and then share with others, right? It's basically new forms of data. So actually, like when you look at Vego Light in your own, you can, in your own websites, you're gonna have a save screenshot, or you can allow your website to export something or create a categorization and export it. So this idea of record is about that. Similar to annotation, the idea to annotate is to basically, when you learn something about a visualization or you create some new knowledge, you can add it to the visualization for others to see. Essentially, it's adding new data, recording annotations, sharing with others. So this is an old app that I created. It was about when you found something about a certain area in Los Angeles, you could write about it and say, maybe there's a nightclub in here and there's a lot of party happening. But this is something that we do every day with Google Maps, right? So maps.google.com is already annotated for me with some of my friends' locations that I go to. But even if you want to go to a restaurant, you can see, or a place, you can see that there's like reviews or pictures. These are all these tasks that have been enabled for this map visualization. Or just, you might, again, remember the hood maps that I'm not gonna show it to you because that's for the future. But hood maps is another one that's really interesting. But yeah, you can, in Google Eats, in Uber Eats, or in all sorts of maps. This is a sort of annotations that's done by people. So searching is another type of task. We can divide searching into subtasks that you can help people do. You can have them look up, locate, browse, or explore. So you can think of these different tasks based on whether the user knows the target they're looking for or not, right? So if the user knows the target and the location they want to look for, this idea is lookup. They just want to find it, right? If they want to look at, see where in the data set, what data points are in an attribute space, that's called browsing. What were the movies that sold more than that? That is a search. Or if you don't know where you want to look, what an attribute is, you can search for it, right? So for example, Mario, how much did Mario sell? That's a search, right? And for both of them, if you don't know anything, you can just explore, right? You can just say, okay, I don't know what I want to do, or I don't know what I'm going to eat, but I'm just going to look at, oh, this looks interesting. Oh, there's like Japanese food. I'm going to go walk here, maybe. So you're searching through a visualization to find something, or maybe you're a tourist. You don't know where to go in Vancouver. That's a target unknown, location unknown type of task, right? So examples of lookup again are find a specific game, find a specific genre, right, in the data set. So here, where is Call of Duty? Where are they, right? So you can highlight the Mario games and help people find them. When the target is unknown and location is given, it's basically a matter of browsing for specific categories of genres, for example. And for exploration, the idea is that nothing is known. You click around, find games to play, find similar games similar to ones you like, right? This is a notion of exploration. And query is when we have something of interest, we carry out queries about them, basically based on a scope. Sometimes you have a single target which you want to identify. When you have multiple targets, you might compare, or when you have all targets, you might analyze. Again, this is a quick summary of the Monsner book. So to compare, you get a subset of all target data, items based on a query. You do something with it. It's similar to filter, right? So you can say, how does the sales value of action games and puzzle games compare? And then you can go to this and say, oh, puzzle games sold less than action games. That's a comparison task. How did Dota 2 sell at night? What is the player number of Dota 2 at night versus during the day? Or how does it compare to this game, Banana? Do you guys know the game Banana? Do you know why it doesn't have drops at nights? No one has heard of Banana? Wow. You don't know what it is? Banana is a game where you just have a banana in it. You have different types of bananas. Let's look at it. The craziest game. It's nothing. You don't do anything in it. It was the
on
most
June 11th, 2024,
popular game on Steam.
Despite the absolute simplicity
That's
of the
it.
program, its those for Steam rewards are
You
distributed.
can buy. You click on it,
from the revenue function,
and then you can sell it.
Drop of a game here, but you get
see all the different bananas.
On the other hand, it can be seen as a way for the developers to profit off the work of the community.
No, it's nothing. It's not running overnight. There's no thing. You just run it overnight. You do a bot or something, and then you just own a banana, basically. More unique bananas. Crazy. It's a crazy game. It's a nothing game, basically. Versus Dota 2. So it's based on this comparison, you can get somewhere. What are the top games right now? Still Dota 2? Arc. What's Bongo Cats? See, I don't know. I don't know what these games are anymore. Anyways. To summarize basically is to query and summarize. The idea is to yield all tasks, all target, and then get descriptive statistic like these tasks. Compute derived value. It's similar to determining range, finding a streamum, or characterize a distribution. So the summarization is to tell you, oh, what was the average sales of X? Or how would you tell me is the average price of restaurants in Kitsilano or something, right? So these actions are verbs and the targets are nouns. That's how you can think about it, and you can form sentences. And this is a very useful way for us to think about visualizations. So in your assignments and in your next assignment and overall in your projects, I want you to use these terminologies. It's very important, okay? To be able to think specifically why a user might want to do something. Do they want to compare something? And if they do, then you go to your perception knowledge and say, how can I help them compare better? If you wanted them to enjoy something, what enjoyable colors am I going to give them, right? So on and so forth. That's it for today. I don't have anything more to say in terms of this. Hope the Vego Light examples were useful for your assignment. I'm going to post this video tomorrow. And yeah. And if you haven't played Balatro, I love this game. Shout out to Balatro. Okay, any other questions? If not, we can adjourn. Have a good rest of the day and week, and I'll see you on Monday.